1, unit 4, stack and queues. Contains what is stack and representation of stack, stack operations, stack implementation using array and linked list, what is queue and representation of queue, queue operations, queue implementation using array and linked list, different types of queues. Okay, we'll study one by one. So first, what is stack? Stack is a linear data structure in which items are added or removed only at one end, called top of the stack. The stack is based on last in first out principle. So let's take an example, stack of books or stack of plates. The top location of stack or point of addition or deletion is maintained by pointer called as top. Okay, so as shown in below figure, the top of the stack is now 19. Okay, and the memory there again showing the memory addresses of the stack which are stored in a memory location. Okay, so next, adding an element to stack is referred as push operation, while deleting an element from stack is referred as a pop operation. So stack is having two operations, which are those? Push and pop. Okay, so as shown in the figure, above figure, see now this is a push operation, means we are inserting the element to the stack. So first we have a stack of 3 elements, that is 10, 20 and 30. So we are going to push the 40 element, so it will be pushed to the top of the stack. So top will be incremented by 1 and that element will be pushed to the stack, right? So push operation involves following subtasks: receiving element to be inserted, incrementing the stack pointer to top, storing received element at new location of the top. Okay, so these are the tasks before we are going to insert the element to the stack, right? If the stack is full and there is no more room to push any new element, such condition is called as a stack overflow, right? See, so the stack contains only 5 memory locations, so we can store up to 5 elements in the stack. Okay, if I want to store a 6th element, so that time stack overflow will be message will be displayed. Okay, so next is a pop operation. Pop operation involves following subtask: retrieving or removing element at top of the stack, decrementing stack pointer, that is top, right? So see now, so our stack contains now 4 elements, 40, 30, 20 and 10. So top of the stack element is 14 now. Okay, and top pointer is pointing to the top of the stack, that is 40, right? So if I do the pop operation, so first element will be removed first, right? So the now 40 element will be popped out. Okay, popped out, and the stack contains only 3 elements, that is 10, 20 and 30 as shown in above figure. If the stack is empty and pop operation is performed, then the situation is called as a stack underflow. Okay, if the stack does not contain any elements, okay, so that time stack underflow situation occur. Okay, so there is a two types of stack implementation. One is using array and one more is using linked list. Okay, so let's see the array implementation. Okay, so push operation. The push operation involves checking whether or not stack pointer is pointing at upper bound of array. Okay, first we have to check out the pointer is going to pointing to the upper bound of the array. If it is pointing to upper bound, then message should be displayed stack overflow. Okay, so if it is pointing to the upper bound, we have to display the stack is overflow. If it is not, the stack pointer is incremented by 1 and the new element is pushed at the top of the stack. Okay, so let's see the algorithm of the push operation. See, step 1 start. So step 2, if top equal to max minus 1, go to step 3. So max will be the, we have to specify the stack size, how many data elements you want to insert. For example, consider as a 5 elements. Okay, so max will be 5. So 5 minus 1, if top equal to 5 minus 1, that is 4. So top is equal to 4, go to step 3 or else go to step 4. Okay, so consider if the top is 2. Okay, so 2 equal to 4, go to step 3. It is not equal to 4, right? So go to step 4, that is set top equal to top plus 1. Stack of top is, so stack of top is 2, 2 equal to element, so we are going to store that new element to the top of the stack. Okay, and pointing to the top of the stack now. So next step is stop. Okay, so this is the push algorithm of array implementation use of stack. Okay, so next we see pop operation of array. The pop operation involves checking whether or not stack pointer is pointing to a null. If it is pointing to a null, then message should be displayed, that is stack underflow. Okay, so if the stack does not contain any elements, or okay, so that time you have to display stack is underflow. If it is not, then that is being currently pointer is popped from stack and the stack pointer is decremented by 1. Okay, see, let's see the example now. Algorithm. Step 1, start. If top equal to -1, go to step 3 or else go to step 4. Okay, so if top equal to -1 means the stack does not contain any elements. If this condition is true, the stack underflow message will be displayed. If it is not true, then go to step 4, that is return stack of top, means we are going to print that first element. Then set top equal to top -1, so we are going to decrement the top pointer by 1. Okay, so then next step is stop. Okay, so this is the pop operation, pop algorithm. Okay, so next we see linked list implementation of stack. Okay, so push operation. Okay, you know linked list, right? So linked list is a collection of data elements and nodes. Okay, right? So linked list is having nodes. So nodes having two parts, that is first one is info part and next one is the next part, next pointer, right? So two parts. So info contains data values or data elements, we call it as, and the next value contains the next address, next node address, right? So that is called a linked list. So we see the push operation of linked list implementation. The push operation under linked implementation of stacks involves following tasks: reserving memory space of size of stack element in memory, storing the pushed value at new location, linking a new element with the existing stack, updating stack pointer, right? So first we have to create a linked list node, right? Storing that pushed value at new location, we have to store that information into info, right? Linking new element with the existing stack. So if the linked list contains any elements, okay, so we have to link the new node to the linked list old list. Okay, then update the stack pointer. Okay, then that new node pointer is going to point to the existing node. So let's see the algorithm. Step 1, start. Set pointer equal to struct stack star malloc size of struct stack. Okay, so it creates the new node and we are going to pointer ptr is element, so we are going to store the value into the ptr element. Okay, so that is a node info, right? So we are going to store the value into that info field. Then next is the pointer next equal to top, so that is going to point to the next node address location. Okay, so then set top equal to ptr and stop. So this is the push algorithm for linked list. So now we see pop operation of linked list. The pop operation have some tasks: checking whether stack is empty, retrieving top element of stack, updating stack pointer, returning retrieved values. Okay, so these are the tasks, we have to check it out before going to pop the element from a linked list. Algorithm now. Step 1, start. If top equal to null, go to step 3, yes, go to step 4. If top equal to null means linked list does not exist or does not contains any data elements, so that time it will show the stack is empty or linked list is empty. Then set temp equal to top of the element. Okay, so first we have to set the first element. It is, if it is created the first node, then we have to set the temp equal to top of element. then top equal to top of the next, return temp. So it should return the popped value. Okay, so this is the pop operation of linked list. So next we see queue. What is queue and representation of queue? Now queue is a linear data structure that maintains a list of elements, right? The elements are inserted from one end of queue called rear and deleted from other end of queue called front. So queue is based on first in first out principle, right? Example, people standing at movie ticket counter in a queue. Above figure shows logical representation of queue, right? See here now. So this is the queue now. So here 4 members are standing in the queue. So here each element will be inserted from the rear end. Okay, so if you want to insert a new element, we have to increment the rear pointer by 1 and we have to insert that element, and rear pointer will pointing to that element. Okay, if you want to delete the element from the queue, okay, so first we have to read the element that is first, which is we inserted with first, so that element will become first here. Okay, so first we inserted 10 element, right? So first will be come out from the queue, that is 10. Okay, so first 10 will be removed, means the 20, 30, 40 and 50 will remain in a queue, and it is incremented by 1 and front will pointing to the 20 element. Okay, so like this the queue will be working. So let's see the queue operation now. The insert operation adds an element at rear end of queue, while delete operation removes an element from the front of the queue, right? So as per the below shown figure. Okay, so if you want to insert a new element, you have to insert from a rear end. If you want to delete the element from the queue, means you have to delete from the front end. Okay, and insert operations having some subtasks: receiving the element to be inserted, incrementing the queue pointer rear, storing the received element at new location of rear. Okay, so this will be the insert operation task. Then we see the delete operation of queue: retrieving or removing the element from the front end of queue, store it in variable. Okay, increment the queue pointer front to make it point to next element in a queue, return the variable. Okay, so like this we have to delete the element from the front end, right? So this is the operation of queue. So how we are going to implement the queue using array and linked list? So insert operation. The insert operation involves checking whether or not queue pointer rear is pointing at upper bound of array. If it is not, rear is incremented by 1 and new item is added at the end of the queue. Okay, so this is we have to maintain the while inserting the element to a queue. Okay, so let's see the algorithm of insert. So we have to check out step 1 start, step 2 if front equal to null, go to step 3, else go to step 6. Okay, so front equal to rear equal to 0. If queue does not exist, means the front will be equal to null. Okay, or else go to step 6. If rear equal to max minus 1, go to step 7, else go to step 8. If this condition is true, you have to go to the rear equal to rear plus 1 and store that element into a array or a queue. Okay, if it does not exist, go to step 7, display the queue is full. Okay, so this is the insert operation of queue using array. So delete operation. The delete operation involves checking whether or not the queue pointer front is already pointing at null. Okay, if it is not, item that is being pointed is removed from queue and front pointer is incremented by 1. Algorithm as follows: delete operation start, step 1, step 2 is in front equal to null means and rear equal to null, go to step 3, or else go to step 4. Okay, so if this both the condition is true, then queue is empty will be displayed, or if it is not equal or if it is not, that condition is false, then step go to 4, that is front not equal to null and front equal to rear, go to step 5. If the any one condition or all the condition becomes true, then go to step 5, or any one condition false means that will go to step 5, step 8. Okay, so both the condition true, set I equal to q of front, set front equal to rear minus 1. So first we have to read the element, that is step 5. I equal to means we have to store that front element in a I variable, then we have to decrement it by 1 and return deleted element I and go to step 10, so that is stop. Okay, so this is the delete operation of q. So next we see insert operation of linked list using q. Okay, the insert operation under linked list implementation of queues involves following tasks: reserving memory space of size of queue element in memory, storing the added value at new location, linking the new element with the existing queue, updating the rear pointer. So let's see the algorithm. So step 1 start, step 2 set ptr equal to step, here we are going to create the node, right? So set ptr equal to element, first then we are going to store that element into the element ptr element means in a info field. Okay, so if front equal to null, go to step 5, or else go to step 7. If this condition is true, go to step 5, that is front equal to rear equal to null equal to pointer, or set ptr of next equal to null, go to step 7. Okay, so step 7 is set rear points to next ptr, then set ptr of next equal to null. Okay, set rear equal to ptr. So here we created the created the one node, and we inserted the element into that info field, and we are setting that node. If it is only one node is existing, we are setting the next field to a null value, or if it is having another existing node means we are going to point that next pointer to that node. Okay, so this is the operation of insert. So next we see delete operation, checking whether the queue is empty, retrieving the frontmost element of queue, updating the front pointer, returning retrieve value. Okay, so algorithm of delete is step 1 start, step 2 if front equal to null, go to step 3. Okay, so step 3 is display the queue is empty. If the front queue is not null means front is not equal to null, go to step 4, that is step 4 set I equal to front of element. Okay, set front equal to front of next, so we are going to pointing that element to the next element because we deleted that element and we stored in a I variable. Return deleted element, that is I, and stop it. Okay, so here it will print the I element. So this is about queue using linked list implementation. So next we see the different types of queues. Okay, so first, circular queue. A circular queue is a queue whose start and end location are logically connected with each other. Okay, if we continue to add elements in a circular queue till its end location, then after end location has filled, next element will be added at beginning of the queue. Thus, if a queue is filled till its capacity, then start location will be checked for space. If it is empty, new element will be added there. Okay, see, of the as shown in figure, we can store up to 8 elements in a queue because memory location is only 8. Okay, so front and rear pointer is pointing to each other. Okay, means it is connected logically, right? So front and rear. Okay, so it is called as a circular. Okay, so if we can check the queue is full or queue is underflow. How? If the rear and front both are pointing to the same location, it means queue is empty. Okay, if the front pointer is pointing to the first location and the rear is pointing to the last location of that circular queue, means the queue is full. Okay, so we can check like this in a circular queue. So next we see the priority queue. Priority queue is a type of queue in which each element is assigned certain priority such that the order of deletion of elements is decided by their associated priorities. Okay, the order of processing or deletion of elements in a priority queue is decided by following rules. Okay, if you want to delete the elements, you have to follow these two rules. An element with the highest priority is deleted before all other elements of lower priority. Okay, if two elements have same priority, then they are deleted as per other order in which they were added into the queue. Okay, so in a priority queue, for each element they given certain priorities. Okay, and depending on the priorities, we have to do the operations on those elements. Okay, so next one is the double-ended queue. A double-ended queue is a special type of queue that allow insertion and deletion of elements at both the ends. Okay, that is front and rear. We can insert the element from front end, or we can insert the element from rear end. Okay, so elements can be added or deleted from both the ends, but in the middle, hence it is termed as a double-ended queue. Okay, so double-ended queue is categorized into two types: input restricted DQ, output restricted DQ. So input restricted DQ means it allows deletion from both the ends but restricts the insertion at only one end. Okay, so it is called as a input restricted DQ. Okay, next one is output restricted DQ. It allows insertion at both the ends but restricts the deletion at only one end. Okay, as shown below figure, for double-ended queue, following four operations are possible: I front, insert at front and end of queue. Okay, and D front means deletion from front end of queue. I rear means insertion at rear end of queue. D rear means deletion from rear end of queue. Okay, so as shown in the below figure, so this is the example for double ended queue, right? So we can insert the element from both the ends. Okay, so front and rear pointers pointing at the front and rear. Okay, so we can do the both operation at the both the ends. Okay, so this is about double-ended queue. So these are the questions. Thank you.